Electric eels, which are not true eels but knife fish, originate from South America, specifically within the vast river systems of the Amazon and Orinoco basins. These waters provide a perfect environment with slow-moving streams, swamps, floodplains, and muddy river bottoms where electric eels thrive. They are particularly well adapted to environments with low oxygen, which is common in the stagnant or murky waters they inhabit. Because of this, electric eels have developed the unusual ability to breathe air directly, surfacing regularly to gulp oxygen, a necessity since up to 80% of their oxygen intake comes from air rather than water. Their habitat is often characterized by dense vegetation and shallow water, offering plenty of cover and hunting opportunities. During the rainy season, when rivers flood into surrounding forests, electric eels spread out into the newly submerged areas, where prey becomes abundant. When waters recede in the dry season, they retreat back into deeper pools and river channels, sometimes congregating in the same areas due to reduced water availability. One of the most fascinating facts about electric eels is their ability to generate powerful electric shocks, which they use not only for hunting but also for navigation and communication. What makes this especially interesting is that they can emit both weak and strong discharges. Weak charges are used almost like radar to sense their surroundings in dark or murky waters, while strong discharges can stun prey or deter predators. The jolts can reach up to 600 volts, enough to incapacitate much larger animals and even pose a danger to humans. Electric eels are not always solitary, as once believed. In some regions, groups of electric eels have been observed hunting cooperatively, herding schools of fish together before launching a coordinated electric attack. This kind of group hunting behavior is extraordinary for a species once thought to be strictly solitary and shows a level of social strategy that scientists are only beginning to understand. Electric eels are not considered rare, but their distribution is limited to specific parts of South America. They are fairly common within their natural range, which includes the Amazon and Orinoco river basins. Because these regions cover vast expanses of waterways, electric eels have plenty of habitats in which they can thrive, from large rivers to swamps and floodplains. Their ability to adapt to oxygen-poor waters by breathing air gives them an edge in surviving conditions where many other fish cannot, helping to maintain stable populations. Despite their abundance in the wild, electric eels are not often encountered by people. This is partly because they prefer murky, slow-moving waters with lots of vegetation, making them hard to spot. Additionally, their tendency to avoid human activity keeps sightings uncommon. As a result, many people might assume electric eels are rare simply because they are elusive and live in remote, difficult-to-access habitats. Electric eels are not currently listed as endangered or threatened. However, like many aquatic species in the Amazon, they face risks from deforestation, water pollution, and habitat destruction caused by human activities. Climate change and the alteration of river systems could also affect their habitats in the long term. Even so, they remain relatively widespread and resilient compared to more fragile freshwater species. While electric eels may seem mysterious or uncommon to the outside world, in their native environment they are a regular part of the ecosystem and play an important role as both predators and prey. Their reputation for delivering powerful shocks may overshadow the fact that, in the waters of South America, they are neither scarce nor disappearing, just well hidden. Electric eels have a distinctive appearance that sets them apart from other freshwater fish, though they are not true eels but rather a type of knife fish. Their coloration is typically a dark grayish-brown to black along the back, which helps them blend into the murky river bottoms where they live. The underside is usually lighter, sometimes with a yellowish or orange tint, providing a subtle counter-shading effect. This muted coloration is well suited to their environment, making them less visible to both predators and prey in muddy waters. Their build is elongated and cylindrical, much like an eel, but with some unique differences. Electric eels lack dorsal, pelvic, and caudal fins. Instead, they have a long undulating anal fin that runs almost the entire length of their body. This fin allows them to glide gracefully both forward and backward through the water with a ribbon-like movement. Their body is muscular and streamlined, designed to house the powerful electric organs that occupy most of their length. Electric eels are among the largest freshwater fish in South America. Adults can grow up to 2.5 meters in length, making them the largest members of the knifefish family. Their impressive length is necessary to accommodate the large electric organs that generate their shocks. Electric eels can reach up to 20 kilograms, though most individuals are lighter. Their weight depends largely on age, health, and habitat conditions. While not the heaviest freshwater fish, their combination of length and muscle mass makes them formidable predators in their environment. Electric eels are generally quiet creatures and do not produce sounds in the way many other animals do. Unlike frogs, birds, or dolphins that rely on vocalizations, electric eels communicate and interact with their environment primarily through electrical signals. Because they live in murky, low-visibility waters, sound has not become their main form of communication. Instead, their remarkable electric organs have taken on that role. Instead of audible noises, electric eels emit weak electrical discharges that act much like a language. These signals can be used to navigate, identify objects, and even recognize other eels in the water. Scientists have found that different patterns of electrical pulses may convey different types of information, functioning almost like words or codes in a silent conversation. For example, an eel may send out rapid, rhythmic pulses to alert another eel or slower signals to map its surroundings. Although they do not produce sounds humans can hear, some researchers compare their electrical communication to a form of silent signaling, similar to how bats use echolocation clicks, except in the eel's case, the messages are electrical rather than acoustic. In a sense, their electrical emissions have replaced the role that sound plays in many other species' social and survival behaviors. Electric eels are highly specialized hunters, relying on their electric abilities to locate, disable, and capture prey. They use a clever two-tier system. Weak electrical pulses act as a kind of radar, helping them sense movements in the murky water, while strong discharges are used to stun or paralyze prey. One of their most fascinating hunting strategies is the double-tap method. By delivering quick bursts of electricity, they can force hidden prey, such as fish buried in mud or vegetation, to twitch involuntarily. This betrays the prey's position, allowing the eel to move in for the strike. Once the prey is located, the eel can release a powerful electric shock, sometimes exceeding 600 volts, to immobilize it completely. They can wrap their bodies around prey to deliver a continuous electric current, ensuring the target cannot escape. This is particularly effective when dealing with larger or more resistant prey. Electric eels are mostly solitary hunters, but recent studies have shown that in some areas they can engage in cooperative hunting, working together to herd schools of fish before launching synchronized electric attacks. This social hunting behavior is rare among fish and highlights their adaptability. Electric eels are carnivorous and feed mainly on fish, which make up the bulk of their meals. However, they are opportunistic predators and will also eat amphibians, crustaceans, and even small mammals or birds that venture too close to the water. Juvenile eels feed mostly on invertebrates like insects and shrimp, gradually shifting to larger prey as they grow. Their ability to subdue animals bigger than themselves with electricity gives them a wide range of food options compared to other river predators. Electric eels have a unique and somewhat mysterious breeding pattern, as much of their reproduction takes place in the remote and muddy waters of the Amazon, making it difficult to study. What is known is that breeding generally occurs during the dry season, when water levels are lower and fish are confined to smaller areas. This timing increases the chances of survival for the young, as it is easier for the parents to protect them and for the fry to find food. One of the most remarkable aspects of their reproduction is the role of the male eel in nest building. Unlike many fish species, the male constructs a nest using his own saliva, creating a foamy mass that floats at the surface or attaches to vegetation. The female then lays thousands of eggs in this nest, where they remain relatively safe from predators. A single female can lay up to 3,000 to 17,000 eggs depending on her size and health. After spawning, the male guards the nest, a rare behavior among fish. He protects the eggs from intruders and ensures they remain in the nest until hatching. Once the larvae emerge, they feed initially on the yolk sac before transitioning to small invertebrates and gradually moving up the food chain. This parental investment, particularly from the male, greatly increases the survival chances of the offspring in the challenging Amazon environment. Because of the eel's reliance on low-oxygen waters and the need for careful nest building, successful breeding is not easy in captivity. This is why electric eels are seldom bred in aquariums. Most specimens on display are wild-caught rather than captive-born. Thanks for watching. Please subscribe for even more viewing pleasure. Don't forget, like and comment. Feel free to share.